final session, which is on big data infrastructure to unlock the power of machine learning and AI. I'm related to be joined by our esteemed speaker, Joshua Arvin Lat, the Chief Technology Officer, NuWorks Interactive Labs. Well, Joshua is an AWS machine learning hero and has spearheaded and led the machine learning zero to hero online international events. Well, if you may have any questions for our speaker, do put it on the Q&A tab. It'll be answered at the end of the session if time allows. Well, with this, we'd really like to welcome Joshua on the stage and screen. Thank you so much, Joshua, for joining us live at the World AI Show Australia. Over to you.
All right, thank you for that. I'll share my screen. And
Perfect. How are you doing, Joshua?
Great. Yeah. All right. Can you see my screen?
Yes, we can. Thank you. Over to you.
Okay, I'll start. So good day, everyone. So this is going to be a quick talk on big data infrastructure to unlock the power of machine learning and artificial intelligence. So to quickly introduce myself again, I am Joshua Arvin Lat. People call me Arvs. I am the Chief Technology Officer of NuWorks Interactive Labs. We offer different services like development services, machine learning engineering, and so on. And then I'm also an AWS machine learning hero. And I am an author of a machine learning engineering book called Amazon SageMaker Cookbook. So it will be released in about 3 months from now. I'm also one of the certification subject matter experts in machine learning. So if you have taken, let's say, the AWS machine learning specialty exam, I'm one of the people who contributed to that exam. So pretty cool, given that I'm able to contribute and share my expertise and knowledge in machine learning and machine learning engineering. That said, enough about me. Let's now talk about the main topic for this session. So just to quickly have a recap on the applications of machine learning and AI, here are some of one of the more common use cases when it comes to machine learning and AI. So that would include chatbots, recommendation engines, optical character recognition, sentiment analysis, anomaly detection, and document classification. So some of this, if you are familiar with deep learning algorithms, you would probably be aware that some of these are solved with deep learning. And the advantage there is that if you have more data, you are able to use more complex algorithms, and therefore you'll have more complex models, which will allow you to have more accurate results. Of course, that's generally how it behaves. But definitely, the more data that you have, the more opportunity that you have to produce a more accurate model. So let's take a step back and then spend the next 15 seconds trying to count the number of apples in this slide. So basically, the goal is to count the number of apples in this slide. And then if you get it correctly, I'll give you a prize. So let me start. So 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So if you tried to guess the number of apples in this slide, and if you tried, let's say 15, that's incorrect. If you tried, let's say 18, that's also incorrect. Or 20, 21. The funny thing there is that they're also incorrect. So what's the correct answer? It's impossible to count the number of apples in this slide. So it's a trick question. Why? Because for one thing, we can only see the top layer, and we are not able to see what's underneath. And the same with the data sets, the same things that we manage, the resources that we manage, we are only able to see what's available, depending on the tools, depending on the context, and depending on the visibility that we have on the data. And the same goes for the data sets that we're handling. If we're dealing with a relatively large data set, we can only do so much if we don't have the capability to count things properly. So let's say that you're trying to count 10 apples. It's completely different if you're trying to count 10 million. So that said, it's important for us to understand the additional steps that we usually do when we're dealing with machine learning experiments. So here at the left side here, we have more or less a messy pool of files. Let's say a bunch of JSON files, and then we just push all those data and those records in a data lake. So what we do there is that we organize that data into, let's say, a table structure, something that we can easily analyze. And then we optimize that table, let's say it's a big table, we optimize that into and serialize it into protobuf record IO format. So if this is the first time you've heard about the protobuf record IO format, basically this helps optimize the training time, because you are able to perform training right away as the data is streaming, even if the entire data set is not yet loaded to let's say the machine learning instance doing the training job. So we are combining both infrastructure and a few techniques when it comes to data processing in order to speed up training, as that is basically one of the things that we want to improve on, especially when dealing with machine learning experiments. And also, if this part here on the left side is quite big, it would be hard to manage the infrastructure there, especially if we have to process all of that, store that in memory, and then pull the necessary information that we need for our experiment. So let's say that if we were to use SQL to abstract things a bit and then extract the information using SQL statements, then we need to look for the right technology to help us with that. So options there would be, let's say, Presto or maybe Amazon Athena. So with Amazon Athena, for example, you won't have to manage the infrastructure. You don't have to have those clusters available. Basically, it allows you to run SQL statements on top of a storage service, and then you can extract the data, whether they're big or small. You don't have to manage the infrastructure. The challenge usually when dealing with big data infrastructure is that, one, you have to manage the infrastructure. And then second, you have to deal with the cost. So you want to make sure that when you're doing experiments, you're getting the best model out there. At the same time, you're able to manage cost and time, and also the resources needed to manage everything. So the less time you work on infrastructure, the more time you have to work on the experiment itself. Next, in training and development, so this one is simplified. There are definitely other options when it comes to deployment, but the protobuf record IO file that we have generated can now be used for training. So we now train the model, and then we deploy that model. Of course, we analyze it first, and then we deploy the model into a machine learning inference endpoint. So with that inference endpoint, you can do real-time inference, or maybe another option is if you have the model, you can perform batch inference by running a transform job or something. So that said, you can see here that the resources needed to train the model and then the resources needed to deploy a model may not be of the same size. What do I mean by that? Meaning that the training resources or the training instances needed may be much bigger than the resources needed to deploy it. So maybe once you have deployed the model, maybe you no longer need the GPUs. Maybe a CPU would do the trick, and maybe a smaller computer or instance would do just fine. I'll talk about that later. But what I can say here is that we cannot afford to have an over-provisioned computer or instance just to do all of this. So the more we can make use of cloud computing resources, which are scalable and on demand, the better. So now, if you are performing experiments, the experiments will definitely not work right away. A more practical approach is to basically try to do things end-to-end first when dealing with machine learning experiments. So here at the top, you can see that we have a relatively small data set. We are probably just getting 5% of the total data set so that we have an idea about the structure of the data. We download that data to the machine learning instance, and then we perform training. So we will probably get to finish training in, let's say, 3 to 5 minutes, right? And then you have the model. And once we want to have to prepare the model for the entire data set, then that's the challenge there, because usually it's not easily that scalable to manage the same type of problem, but with a bigger data set. So for example, you're just dealing with 30 records in your proof of concept work. And then when you have to work on, let's say, 10 GB of data, things would be much different, because for example, instead of, let's say, 3 minutes, it's going to be 1 hour. Or maybe you may need a bigger set of resources, like let's say from M5 large will need M5 2x large. So basically, you can see here that you will need larger resources to handle this. And if the platform that you're using does not allow you to do that, try to find ways to make it work for you. Because what we want to do here is to abstract the infrastructure as much as possible and just perform a few tweaks so that you can perform the same experiment, but with a larger and stronger infrastructure to support the experiment. So here are the different steps in the machine learning process. What we want to do here is that the infrastructure to support the experiment ideally is as scalable as possible, meaning that if we just need two computers or 2 servers to perform the data preparation and cleaning step, then we just specify 2 in the parameters. And let's say that we want to perform pre-training bias analysis or post-training bias analysis. Then that's something that should be scalable as well. So if we would need one large instance, then we can use, let's say, SageMaker Clarify to perform that for us, so that we will have the SHAP values, for example, or maybe we will have the bias metrics that would help us analyze if there's something wrong with our data. And then for model evaluation and model deployment, definitely we may need much smaller resources, much less powerful resources to handle our requirements. And then finally, for deployment, given that those resources will be up most of the time, we want it to be as small as possible. So if we can find a way to put it in a really small T2 medium computer, then that's the goal. Next, with the big data infrastructure, if we were under the assumption that we can turn on and off resources on demand, this means that we can automate a lot of things along the way. So let's say we want to automate data processing. Yes, we can automate that. A server will, an instance would spin up, it will be provisioned, and then it would pull the data, process the data with a custom script, and then output the data somewhere. And then once it's done with the processing job, we are able to turn off that server right away. So that saves us cost. So that's the advantage of using cloud computing to manage our experiments. Another option and another thing that's cool here is that we are able to perform automated hyperparameter tuning in order to give us the best model available through the different combinations of hyperparameters. So that said, let's say we want to perform model tuning on different algorithms and different model families. We are able to do it with just a couple of parameters, and different computers and different servers will spin up, and all of them will try to run all at the same time. And then once all the training jobs are complete, we pull all the models, we evaluate them, compare the results, and then use, let's say, a target objective metric to give us the best model out of all those training jobs. So that's pretty cool here, because you don't have to worry about managing the infrastructure. Basically, what we want here is to focus on getting the best model. And yeah, even if the data is big, you can just specify, okay, I just need a larger computer to help us with this. And then you can manage the time and cost for this experiment. And then finally, if we are able to divide those parts of the process into different parts, let's say data preparation, analysis, data extraction, feature engineering, and then model training, evaluation, and then deployment, we can technically automate those further with workflows. So regardless if we're dealing with a smaller data set or with a data set that's close to big data, then we can use workflow automation services. So for example, here, we combine Amazon SageMaker and step functions. So SageMaker is the managed service of AWS, which would help us automate a lot of stuff for us and abstract the infrastructure to help us with our machine learning experiments. And then step functions would help us manage the workflow. So if there's an error in the training step, you would be able to manage that and process the logs properly and process the error messages properly, so that it's much easier for us to debug what went wrong. So there, the advantage here is that a service is dedicated to managing the machine learning experiment infrastructure, and then another service would help you manage the workflows, which can easily be combined with the usage of other services. So that's pretty much it. So in summary, the goal here is to let you guys know that there are a lot of options available now. 5 years ago, what happened before was that ML ops and ML engineering have usually been deprioritized in the sense that people only think about those operational work and engineering work when it's about time to deploy the model. But the problem there is that after you have performed the training of the model, you have to worry also about the retraining part. So of course, the model will drift in a sense that its performance needs to be reviewed regularly, and maybe it may produce weird output at some point. So definitely you have to perform training again. So that said, it's important for us to automate things as much as we can and use the proper infrastructure to support with our requirements. So thank you very much. Hope you learned something new today. And again, I am Joshua Arvin Lat. If you want to reach out, here's my email, and just feel free to connect to me via LinkedIn. Thank you.
Thank you so much, Joshua, for joining us today. We did get certain responses while you were asking the questions. So there was Champ who had replied with the number 18. I don't know if that helps right now to tell you, but then there were certain responses which were coming live when you did ask the question. So thank you once again, Joshua, for joining us and being in the concluding session at the World AI Show Australia. Thank you.
Thank you.